In this video, I'm going to talk about substitution reaction mechanism. Now, in this question, we were asked to give the product and write the mechanism involved. So let's start by writing the product. Now, this is a substitution reaction we're dealing with. So the only thing you need to look at is what is the nucleophile here. Now, the positive end, and we have a negative end. Your nucleophile will be the negative end. So since this is a substitution reaction, all that will happen here is that the Br is going to replace the OH. And therefore, what we are going to get as our product will then be something like this. Okay, so you replace the OH with the Br. Of course, this and this would leave as water. So your product is going to be this alkyl and water. Now let's go to the mechanism. How do you determine which mechanism you are writing? So we have two mechanisms in substitution reaction. We have the SN1 and we have the SN2 mechanism. Now the SN1 mechanism, the first thing we need to know is that the reactivity for SN1 is that tertiary carbocations are much more reactive than secondary carbocation, which is more reactive than primary, and of course methyl group. And usually the primary and the methyl will prefer to undergo SN2 reaction. Okay, so that is why in SN2 reactivity, you have those two as the starting point. So the reverse of SN1 reactivity is what you see in SN2. And tertiary carbocation would prefer to undergo SN1 reaction. So this is one way to know the mechanism you are going to proceed with. The second way is also to look at the solvent phase that you were given. So SN1 reaction would proceed with a weak base, is water and alcohol, the favor SN1 reaction. Okay, now let's look at this. We can see here that this is carbon attached to 3 different carbons. So this is tertiary carbon, right? So this is a tertiary alcohol, and therefore is going to proceed with SN1 reaction mechanism. And SN1 reaction mechanism is a 2-step reaction mechanism. Now, in this particular scenario, the first step is making this hydroxyl group a beta leaving group. The first thing we need to do would be for it to pick the hydrogen here. So when that H attaches, it becomes a beta leaving group. So from here, the substitution reaction mechanism starts. So this leaves, okay, and it forms a carbocation, which the Br that was left is then going to attack that carbon, attaches itself, and gives you the product that we have up there. So this is SN1 reaction mechanism, and that is how it proceeds. Okay, now let's look at the next example. In this example, we're also not sure of what's going to happen here. Okay, and this carbon that is bearing the alkyl group is a secondary carbon, so which means that it can actually undergo SN2 reaction also. And so the next step that will help us determine which of the reaction mechanism to proceed with will then be the nucleophile. So looking at this nucleophile, you are given water. So water is the favor SN1 reaction. The first step in SN1 reaction is the leaving group breaking off, okay? And then that forms a carbocation. And then the water attaches itself, and we have okay. Now you see the whole of the water attaches itself. Now when this happens, we need to remove one hydrogen. So we call it deprotonation. One hydrogen is removed. We use another molecule of water. Take away this, and this bond breaks. So our final product would be an alcohol. Okay, so this is the reaction mechanism for this particular one. All right, let's go to the next example. So in this example, we are given this compound and we are given sodium hydroxide as the base. Now, the first step would then be to determine which mechanism we're working with. Okay. Remember, if you are just asked to give the product, all you just need to do is now look at this. We have the positive end as the metal, sodium, and then the negative end is the OH. So your OH is your nucleophile. So it means that this will be replaced by this. So your product will actually look like this. So that's the product. Now for the mechanism, this here is a secondary alkyl. So you have 1 carbon, 2 carbon. So this is a secondary alkyl halide, which means that it can actually undergo either SN1 or SN2 reaction mechanism. But we then look at the kind of base that was given. Sodium hydroxide is a strong base. Okay. And because it's a strong base, we're going to go with SN2 reaction. So our reaction mechanism will then proceed like this. So in SN2 reaction, the leaving group does not live on its own. Okay, so the step is a one-step reaction. It's not like the SN1 that is a two-step reaction. So this is going to be coming in here, and this will be leaving at the same time. So it happens simultaneously. And then, of course, the OH attaches itself. Okay, so that is the mechanism for SN2. And then for this other one, we have here a primary alcohol. So this is your carbon bearing the OH and is attached to only one more carbon. So this is the primary alcohol, and this already tells us that this is going to be SN2 reaction. Okay, so the first step would then be we have the positive end. I'm going to expand this. So we have the positive end and we have the negative end. So what's going to happen is that this oxygen here is going to pick the hydrogen and this bond breaks, leaving the Cl minus on its own. So that's usually the first step when we're dealing with alcohol. Okay, so we're going to get this. Of course, the hydrogen has been attached, right? And then you still have your hydrogens here. Now the second step would then be the chlorine. Okay, that was, this chlorine here would then attack this carbon. As it does that, this water breaks off. So still one step. So this is where your substitution reaction starts. This here is to make this a better living group. Okay, so our product will then be